Okay, so my goal with this lesson is just to review how to calculate the value of a for a given parabola if you have the graph of it. And that a value, again, tells us whether the graph opens up or opens down. Everybody was pretty comfortable with that really early. And it also tells us the vertical stretch factor of the graph. So it tells us numerically how many times taller the graph is compared to y equals x squared. Y equals x squared is in some ways, the sort of the simplest parabola we can have. We can calculate the numbers really easily, and then we can use it to compare. So here's a parabola. I've got the vertex here is -1, -3, and then these other 2 points, so 1, -1, and -3, -1. So if you don't happen to have a picture of y equals x squared and you need to find, so here we're going to find the a value of this graph. So we need to compare to y equals x squared, so if we don't have a picture, we'll just draw one. And I'll just do this quickly here. Please ask me questions if you're not sure about this, but this should be pretty easy eventually. So if it's not, then come talk to me. So if y equals x squared, I can sort down some x values near 0 here. To find the y value, it's just x squared. So if x is -3, y is -3 squared, which is -3 times -3. So that's +9. Okay, because negative times negative is positive. -2 squared is 4. -1 squared is -1 times -1, which is 1. 0 squared is 0. 1 squared is 1. 2 squared is 4. If I had more space, I'd write that 3 squared was 9. Okay, and then I'll just put these points on the graph. I've got this little graph drawn here. I'll start with the middle. 0, 0 is right there. 1, 1, over 1 and up. Remember to go over first. -1, 1 goes over 1 to the left and up. 2, 4 is over 2, 1, 2, 3, 4 and up 4. And -2, 4 is over -2, so that's to the left and up 1, 2, 3, 4. Okay, so I've got 5 points is enough there. When I connect them, I have to be really sure not to have the point at the vertex look like it's sort of connecting with a V here, because that's different kinds of graphs do that aren't parabolas. And if you ever, just if you've got a minute, you draw a parabola, even one that's really sort of tall, like really tall and skinny, if you zoom in enough on the vertex, it's almost flat, close enough to the vertex if you get close enough. So it's important that you not draw it like a V. They're really hard to draw, so it doesn't have to be perfect, but it has to make it look like you tried to draw it curved the whole way. Okay. So the question is, now we've got that, the next example I'll start with that already drawn. So the question here, back to here, we want to find the a value here. So the question we answer to find that is, how many times taller is my graph compared to y equals x squared? Okay. So if you look at this, you might be able to see just from a quick look, although it's true that my drawings aren't super beautiful, this graph is actually shorter. Okay. So if our graph is shorter, if we could say, for example, that the graph was 3 times shorter, then that would mean it's 1/3 as tall. So 1/3 would be the number we'd be looking for. Okay. So if it's shorter, then our a value is going to be less than 1. Okay? It's like a number like 1/3. If it was 4 times shorter, our a value would be 1/4. If it's 4 times shorter, it's 1/4 as tall, and that's the question that we want. Our a value is how many times taller is it? So here's how you do it. You start from the vertex. It would be slightly easier to find the a value if these were linear functions, because we're looking at something that's sort of similar to the slope. But the thing is that on a linear function, if your graph is a line, then the slope is the same everywhere. And here, the slope isn't the same everywhere. So we have to make sure that we're sort of comparing equivalent places on the two graphs. So I'll always start with the vertex. And then choose another point. I'm going to choose this one just because, just like that point. You get the same answer whichever one you choose. So we're going to compare the vertex And the only trick is to figure out which is the equivalent point here. And this is how you do. You figure out how much did I go over? What's my horizontal sort of displacement? I want to get from -1 to 1. And here it's over 2. So that means we have to go over 2 here as well. Okay. And now we can compare, this is the interesting thing, how tall this is compared to how tall this is. Okay. If you draw in the circles, actually that might have just become clear how much taller it is. So this one, the sort of parent function, the y equals x squared here, if you go over 2 points from the vertex, then you go up 1, 2, 3, 4. Okay, so this is up 4. But over here, when we went over 2, we only go up 2. Okay, so these are the two numbers we're going to compare to figure out how much taller this is. So what we will do there is, if we start with this is the original, so 4 times what equals 2. How many times taller? Okay, and that's the same. 4 times a. Okay, is going to be that's going to be our a value. So some of you may be thinking, oh well, it's not. Some of you just know the answer, and some of you are thinking, oh well, it's not times anything; it's divided by something. So remember. Let's put this here. Remember. Oh, so some people will be like saying, oh, we're just dividing by 2. Dividing by 2 is the same thing as multiplying by a half. Okay, similarly, dividing by 3 is the same as multiplying by a third. So we want to multiply by something, we want to know how many times taller it is. So it's 4 times a half. Gives us 2. So that means that our a value here is 1/2. Okay. So if I wanted to find the equation of graph, say we wanted to find it, maybe I'll just do standard and transformational form. So standard is y equals a times x minus h squared plus k. So our a value we've got right here. So y equals going to be 1/2 times x, let's leave that squared plus something. Okay, so the h value is the x coordinate of the vertex. So our h here is -1. So in this equation, I'm doing x subtract -1. So it's, we're going to write this x minus -1. That's the same as x plus 1. So down here it'll be x plus 1. Right, and then I've got plus k. What's my k value? K is the y value of the vertex, which is -3 here. So k plus -3. Oh, I should have put this in pink here. And then we've got k plus -3, which I will write as k subtract 3. Okay, so in standard form, the way to remember things that are in quote backwards is if we're subtracting a number here, it'll have kind of the wrong sign in the equation. So here it looks, when we look at this, we say, oh, h is -1, so here it'll be +1. Okay. In transformational form, we've got, it's 1 over a times y minus k equals x minus h squared. So another little thing we'll just review up here is that 1 over 1/2. We talked about this earlier. I talked about this earlier in one of the videos. 1 divided by a half is the same as 1 times 1 divided by a half, and that's 1 times, we flip the second fraction and multiply. Or if you can imagine taking 1 and dividing it into pieces that are 1/2 big, and you get 2 pieces. So 1 over a is 1 over 1/2, which is equal to 2. So that number is sort of, in transformational form where it says 1 over a, that means our number in our equation is going to kind of look upside down. We've got times y, and then we're doing subtract k. So it's minus 3, so it'll be plus 3 equals x minus h squared. That's the same thing as we had up here. It's minus 1, so it's plus 1 squared. Okay. So there's the equation in standard form and transformational form. Okay, I'll just do one more example. It'll be much quicker, and we'll just find the value of a. So here's my function I want. This guy over here is the parent function, okay, which you can just whip off anytime you need to, just by squaring on your x values. Okay, so I'll do the same thing here. I've got my vertex, and I need to compare how tall this is. How many times taller? Is my graph compared to y equals x squared. Okay. This one does look taller. It looks taller and skinnier. So this, here we're expecting a number. It'll be larger than 1, like 2, or 3, or 4, or 5. So we start at the vertex. But to know which point, we can choose any point here, really. Maybe I'll use this one. And now to know which point to compare to, I have to go over the same amount. So how much did I go over here? Well, I just went over 1 from -2 to -1. So that's actually easy. Go over 1, and then I see how tall is this compared to that. So this is 1 tall, up 1. This is 2 tall, up 2. So 1 times what equals 2, and that one's easy. A equals 2. 1 times 2 equals 2. Just to show that you could have used another point. Say you wanted to use this point for some reason. Maybe you didn't know the coordinates of these points. Just the reasoning is exactly the same. So you start at the vertex and you say, how much do I go over there? To get from -2 to -4, so that's over 2. I guess it's over -2. So we'll start here and we'll go over the same amount, over -2. So that you always match the horizontal change, and then you compare the vertical change, because we want to know how many times taller. So here's the sort of default height at that point, which is 4. And then the height here, how much is this? So this is 3 high compared to -5. So you can either count or just subtract there. 1, 2, 3, 4, 5, 6, 7, 8. This is up 8. So if we'd done it at a different point, we'd say, well, how many times taller is 8 compared to 2? And it's also double. So the a value is 2. Maybe if I wanted the equation, let's just do it quickly in standard form. So we've got y equals a times x minus h squared plus k. Let's get the h and k values as well. So our h value is the y value, the x value of the vertex, so that's -2. And the k value is the y value of the vertex, -5. So with all these negative signs, be real careful, especially where we've got, if we're subtracting in the sort of way we write this with the letters basically in it, then we're going to have to be real careful with the signs. So we've got y equals, And then here it's just a, so we don't have to worry about any of that 1 over a business. We just substitute our a value there. 2 times x, and it's x minus h, so it's x minus negative 2. So it's going to be plus 2 squared. And then plus k, so it's plus negative 5. You can write plus negative 5 if you want. I prefer writing just subtract 5. So that's the equation in standard form. Okay, so I've just got a couple little practice questions for you. Here, there's 2 questions, but they each have a couple parts. So we've got 2 parabolas. For the first one, I want you to write the equation in a few different forms. Factored form. So think about what those. So that's. I'll let you look that up. It's the one where I'll let you look up. Remind yourselves if you don't remember what factored form tells you about the graph. Standard form, which we just did. General form. So they want, and general C and D, I'll both ask you for general form. So I want you to find it 2 different ways. So the first way, because one of the things about general form is that we know that it gives us the y-intercept, and here we don't know exactly what that y-intercept is. It's like it's between -2 and -3, and it's closer to -3, but who knows exactly there, right? And you can tell from my beautiful drawing skills, probably wherever that is isn't exactly right anyway. So instead of doing it just by using what you know about general form, I want you to do it 2 different ways. This one, by simplifying one of those. You can choose whichever one you prefer. And then the second method, I want you to do a quadratic regression. So you put 3 points in your calculator, and you go to press Stat, and then go over to Calc, and then choose quadratic regression, which you've done once in class. The second question, so you should get the same answer for both of these, although the calculator will give you some, it'll do some things, it'll write your fractions as decimals, and it's better, the way you will write it here with fractions is better. Okay, and for the second one, there's just 2 parts. Write the equation in transformational form, and then write the domain range and the equation of the axis of symmetry. Okay, I'll bring this to class tomorrow. Alright, thanks.